Hello everyone, it's Hangchuan Wei from just graduated from University College London, Bartlett School of Architecture. The title of my research is environmental-driven massing based on machine learning, and it's done by under supervision of Yota and Delamido and my tutor Richard Beckett. Research based on the environment are very important in the field of architectural design, and resist undesirable and take full advantage of environmental factors is one of the original purpose of architects. By answering the environment conditions, architects change their strategy to make the building better for humans to live or work in. And architects used to make decisions based on the tradition, experience, technologies, and the demand of their clients. When it comes close to the modernism, environmental factors such as sunlight, wind, and rain were taken into consideration mathematically and systematically. In architects' design work, we start to see absolute rationality based on nature science is embodied in architectural design. And at the age of computer-aided design, designers start to apply accurate simulation in buildings with the power of computer programs to evaluate the performance of their buildings. The first image shows is from the Le Corbusier's. He shows how he's trying to abstract environmental factors. And the second image is a CFD simulation done by a company called a SimScale. In such approach, by simulate and visualize the environmental factors, architects are able to get information they need to support their decisions. Moreover, to combine software simulation and the parametric design, use this methodology, algorithms can be used to collect and calculate simulation results. We can use the simulated results to influence the building, and this can happen in many aspects of design. The image shows the facade of Abha Towers designed by ADAS. The facade panels will transform as the sun moving. We can see how building responding to the environment in this case. And nowadays, the potential of AI in the field of design has received a great deal of attention. The combination of AI and architectural design has also made many exciting achievements. The image is shows the company SpaceMaker. They use the AI approach to help in the preliminary design of the building, and they achieve encouraging results. And according to the research done by Glanos and Cronis from Australian Institute of Technology, they put forward an approach to realize real-time simulation based on machine learning, and use this real-time simulation, they can achieve a model that can generate the initial design based on exhaustively calculation. The objective of our research is to combine computational and machine learning approach to achieve the real-time simulation and use the model to generate the building design. And then we'll show our methodology and our model. As a machine learning model we use is a CycleGAN programmed by Junyi and Zhu's team. Generally speaking, it requires less matched data sets than other GAN models. The purpose of the training is to achieve a model that can predict the wind environment from the input side. And about the data set, we use AD3D in Grasshopper to simulate the wind environment. Firstly, we use AD3D to get the wind environment over a city scale at different heights, 0 meters, 5 meters, 10, and 15 meters. And then we clip the rendering the simulated results into smaller panels with the size of blocks, which is mostly our construction site will happens. And this is the collection part of our data sets. Yep. And then after the generate the GAN model is obtained, we use it to build our generative model. Firstly, we can put our input site into the model, and the CycleGAN will generate the wind environment based on the input site, and then we can use the then we use like Houdini. In Houdini, we use algorithms to generate the possible boundary in different heights for the building, and after that we put them into the CycleGAN model again, and use it to predict the wind environment of different candidates, following by a calculation and evaluation to see which boundary that which boundary is better for this site. And after we get the boundary in different heights, we can use it to generate to extrude our massing. We can see this is we get our wind environment in different heights and to build different candidates of the boundary. And then we simulate the possible boundary again. And after we get the best candidates in different heights, we use them to generate our massing. Yeah, this is the one result we do for a site in Shoreditch in London, and this is another result we ran in Tokyo. There is a couple of limitations for this kind of workflow. Firstly, there are many steps are simplified and fascinating, fantastic, I think. For example, we ignore the influence of the greenery and also the terrains. And in some cases, we got some buildings that are far more than 15 meters. Yeah. And for second, the portion and the region of the site is hard to control, because when we are using GAN to train to generate the wind environment, it's always using pixel to control the size, but not accurate meters. And for the third one, this procedure still jumps between like Grasshopper and GAN model, and also Houdini. It's hard to obtain. We also put our prospect over that. First, the way of simplifying and fantasizing is help focus on the main objective. For application, facilitating testing and need for the accuracy. And there is no doubt that the model we are using is not perfect. Efforts of computer scientists are always needed to system of application. Designers have for 01 designers have proved that GAN model can be run in Houdini, and that means we can get better combination of machine learning model and those design-based software. And this way shows the potential of like the combination of machine learning and the computational design. Yeah, that's the presentation. Thank you.